You are watching the 3.3 lesson video on graphing linear functions day 2. In the lesson video 3.2, when we were just graphing linear functions, that was the first day of it, you probably remember that we were graphing our lines and they were typically in a really easy format, y equals mx plus b. We sometimes translated from the words into the algebra, but nonetheless, we would always get that nice, pretty form. Well, that's not always how things will look. So what we have to do is turn our equations into that form to make it easier on us. So that's exactly what we're going to do today. We are still going to graph lines, so that won't be new. We're just going to step this up one more piece and go ahead and take our equations and rewrite them so it looks like y equals mx plus b. So the directions for all of the questions below say to translate each written statement into an equation, then B, write each equation in slope-intercept form. That'll be the new part. And then C, of course, after we do this, we would like the graph. So let's begin. Number 1 says the sum. So it looks like we're going to be adding some things. So we're going to add 10 times x, 10 times x, 10x, and 5 times y, 5 times y, 5y, is equivalent to, so is equals 15. All right, so we can see right now that it's not y equals mx plus b. The y is certainly not alone. So in part B, that's what it wants us to do. Now, obviously, on a test or Regents exam, it will not tell you to do this. You'll have to realize, oh, hey, this isn't so easy to graph, so let's put it in slope-intercept form. There's other ways that we can graph this, but right now, let's just talk about the slope-intercept form. So I'm going to use the sorting method to help me with this. So 10x is not a y term. So I want to put my y's over on this side and no y terms on this side. So 10x does not have a y term. Therefore, it moves to the other side and becomes negative. The 5y has a y and it's positive, so drop it down. And the 15 is already on the correct side, so we're just going to bring down the plus 15. Now my last step is going to be to divide each one of my terms by 5, because I don't want that 5 in front of my y. When I do that, and notice how I divided every term by 5, I end up getting, well, 5 divided by 5 is 1, negative 10 divided by 5 is negative 2, and 15, let's not forget our x, and 15 divided by 5 is 3. This is great news now because it is in slope-intercept form. I know where to begin and I know how to move. Let's graph it. So I begin at 3 and I move by going down to the left, or excuse me, to the right one, because the slope is negative 2, and we would write that as negative 2 over 1. So down to the right one. And I will do this to cover my entire graph. Even on the other side. So instead of going down 2 to the right one, I can go up 2 to the left one. And this is nothing new. We did this all in the last lesson. Next, you got it. Let's graph this line by connecting the points. And we can label this either with the original or the new equation. It really doesn't matter. I'm just going to label it with the new. And we're done. All right, let's dive into question 2. So translating twice x. Okay, twice x means double x, or 2 times x plus 4 plus 4. Oh, this is 4 times y. So that's 4y is negative 4. Is means equals negative 4. All right, again, not in slope-intercept form. Let's put it there. Y's, no y's. So the 2x has got to go and become negative The 4y is good because it has a y term, and the minus 4 stays. We just drop it down. Next, let's divide every term by 4, because we need to get y alone. Because 4 divided by 4 is 1. 1y is exactly what I need. So y is equal to whatever negative 2 divided by 4 is. Well, I would like you to use your calculator. Use that TI Nspire to type this in. Because if you're using the Nspire, it's going to spit out negative 1 over 2. And I really like this because the way that it's written is going to help us graph the slope. So the slope is negative 1 over 2, which means down 1 to the right 2. And I begin, however, at my y-intercept, which is right here, negative 1. So here's my beginning point. And then let's follow the rule. Down 1 to the right 2 to cover my whole graph. And because my slope is negative, my line should be pointing downward. And it is. I'm constantly checking that because that is typically where mistakes are made. A lot of times people forget to check the slope, and it ends up actually slanting in the wrong direction because maybe you went up instead of down or left instead of right. And again, let's label this with our new equation. Y is equal to negative 1/2 x minus 1. Continuing on to question 3, it says y less than negative x. Okay, notice how it doesn't say y is less than. That would mean something completely different. That one little word is would change everything. But it says y less than negative x. This means I'm taking away y from negative x. So I took away y from negative x, and that equals 9. All right, still not in slope-intercept form, so let's get it in that form. I'm just going to rewrite it over in part B, copy-paste, okay, and sort it. Y's, no y's. So that negative x will actually move to the other side and become positive x, or positive 1x. The negative y drops down. Don't forget about this guy right in front, that negative, he's important. And then the plus 9. We're almost there. This is a negative 1y. So what I need to do to all of my terms now is divide everything by a negative 1. I don't want a negative y. I just want plain old y equaling my negative 1x minus 9. That's what I got after I divide. So my slope is negative 1, but I write that over 1. So down 1 to the right 1, begin at negative 9. So down 1 to the right 1. Actually, what did I do wrong here? Oh no, I didn't do anything wrong, just kidding. Okay, so down 1 to the right 1. I ran out of space, but what I can do is go up 1 to the left 1 and cover my graph that way. Looks like I'm going to be plotting a lot of points. I just don't mind these straight lines. I'll get rid of this guy right here. This guy's up there. All right, let's graph this. Draw arrows on both ends of the lines and label it. Because the last two I labeled with the new equation, let me label this with the original one that we came up after we translated. Now, before we move on to the next page, I just wanted to show you something that's extremely powerful on the TI Nspire. And if you don't have the Nspire in front of you right now, please go grab one. You need it to graph. So we're in the graphing tab, and I could graph any one of these to check myself. Remember, f of x is the same as y, so I could type in negative 2x plus 3 if I'm checking example number 1, and that should appear. Now, if we hit tab and I want to add a new graph, I also would like to graph this equation here. And right now you can see it's not going to be easy to graph it because it already has the y alone. So what we'll do is we'll hit delete and we get this option here that says relation. Whenever you click on relation, it lets you type in whatever you want. So let's type in 10x plus 5y equals 15. And then you hit enter, and it actually shows right up on top of the other graph because we moved our y all alone correctly. But one thing that I do want to point out, and some of you might be like, oh my gosh, why did we have to show all this work? Well, if you hit Control T, it does not show you the table for the relation ever. It will only show the table of the actual function that you typed in, which is when y is completely alone. So this is a great checking tool. I do not want you using this to just graph after you've translated because that will not help you when you get to a test and you have to show all of your work. Practice doing it this way, but use this as a really awesome checking tool. Okay, moving on to page 14, I would like for you right now to pause the video and take a moment to translate questions 4, 5, 6, and 7 just in the A box. So here we have the answers to numbers 4 and 6. So 2 less than y, 2 less than y is the same as triple, and we're tripling the difference of x and 1. So we're subtracting x minus 1, and 3 is being multiplied to that subtraction problem. That's why I use parentheses. Here's question number 6. 5 times x is equal to the sum of triple y. This one's a little different. We're just multiplying 3 times y, and we're adding 6 to that. And here are the answers to 5A and 7A. Notice how 5 is similar to question 4 with using the parentheses. And you can ignore the red arrow. That's the arrow that I'm using in the next step when you are going to solve for y. Which brings us to that piece. So what I'd like for you to do now is solve for y in each one of the 4 equations. Pause the video and then I'll meet you back. So here we have 4 and 6 both solved for y. Notice how I distributed in this equation and I moved the 2 over all in one step. So I sorted. I'm sorting in most of these equations in case anyone was wondering how I moved things to the other side. So anytime you see, like here I have the plus 2 on the left-hand side of the equation, I'm using the addition property of equality to move that over and become positive on the other side of the equation. Same thing happened over in number 6. With my 3y becoming negative 3y and 5x becoming negative 5x on the other side. Here we have 5 and 7. Again, I distributed and moved the 4 over all in one step. And then 7, same thing. I moved the x over and became negative, then divided everything by a negative 1. Okay, I'm sure you're guessing what I would like for you to do next. Go ahead and graph all 4. Pause the video and start graphing. Here are the answers to the top 2. What is this? 4 and 6. Pause the video if you and down below here is 5 and 7.